Okay, let's take a look at quiz 3 here, right? Starting with question 1. Let me zoom out a little bit. It's telling you, here's, again, an accumulator function. Big F is from 0 to x and is asking for the derivative at 2. So you have to apply the second fundamental theorem, which would give you just the square root of x cubed plus 1, and then go ahead and plug in 2 to that. So I would establish big F prime of x by the second fundamental theorem, get that, plug in 2, and get 3. Oh, here it is again. 2 is practicing your theorem. So F is continuous for a closed interval, a to b. It's differentiable in an open interval. Which of the following could be false? Okay, so this is the mean value theorem, right? So that's why that's definitely true. Let's come back to B later. C, these are two, the conclusions of the extreme value theorem. And E is true because the function was continuous. Okay, so that's why all those are true. This is false. How come? This is the conclusion of Rolle's theorem, but what's lacking up here in the conditions, right? You would also have to have f of a equal to f of b, and you do not have that true. So there's nothing that says b would be true. That's why it's your answer. 3 is no calculator work. It might help to pause it on the screen. So this is your setup, right? Just asking for average value. So understanding the setup is not hard. I think it's the u substitution, right? That is like actually the hard part. So it's really hard to get down to 26/9 as your answer. So from this, we notice a product. We notice it's composite. So those two facts together mean that it has to be a u substitution, right? So I'm going to let u be this because the du would be 3x squared. And that would be off by a power of 3. So the 1/3 times the 1/2 becomes the 1/6 that I have over here in my work, right? And then the du is 3x squared. So when we go ahead to rewrite it, this is simply the square root of u, and the du is the 3x squared, right? Or the x squared, I guess. So you have to change your limits. Instead of 0 and 2, we have 1 and 9. You have to accurately integrate square root of u, which is u to the 1/2, as 2/3 u to the 3/2 by the power rule. And then you have to plug 9 and 1 into that, right? And get 9 to the 3/2, remember, is 3 squared to the 3/2, right? And so those cancel. And so you really have 3 cubed. So this is 27/9 minus 1/9 for 26/9. Okay. On the back, G is differentiable, and G is negative for all real numbers. And F prime is the product of G and x squared minus 4, which of the following is true. So I'm just going to scan these to figure out a direction to go. It's talking about extrema, so I'm going to go ahead and use this and get the critical numbers from this. G is always negative, so when I set that equal to 0, right, G is not going to provide me any critical numbers. So my only critical numbers come from this factor, and those are plus and minus 2. If we do the test points, right, since this is negative, whatever sign you get, right, out of this, right, x minus 2 times x plus 2 times a negative, that'll change the sign of everything that you get. So if I use negative 10 in here, each of these I get negative, negative, negative for a grand total of negative, negative, positive, negative. That's why this guy's positive. And then positive when I test the number 10. These are my test values, right? This will be negative overall. Okay? So we're going to go ahead and go with B, because of the sign changes here. 1 minimum here and 1 maximum here. Okay? 5, instantaneous rate of change. It's just asking you to take the derivative and plug in 2. This is one of those easy questions. You can't miss anything here. This is the one you got to get right. So this is quotient rule, low d high minus high d low, denominator squared. Plug in 2. Be very careful with your arithmetic, right, in order to get 2 as your answer. On the calculator part, number 6, area bounded by these is rotated about the x-axis. So we have to inspect it to figure out, is the sketch and the area that I shade, is this going to be disk or washer, right? And since it butts up to the x-axis, I'm going to go ahead and set up a washer problem. I'm going to write this on my paper, but I'm going to math 9 it. I am not integrating this by hand, so I hope you did not as well, okay? Don't forget pi, because if you don't have pi in your answer, maybe you have b, okay? So the correct answer would be E. The derivative of a function is given by this guy. At what value of x does g change from concave down to concave up? So if we're going to look at the derivative in our calculator, right, it looks like this. So since this is f prime, wherever it's decreasing, that means f is concave down. And wherever it's increasing, that means f is concave up. Okay, and then at this change again, it's going to go back to concave down at these breakpoints, right? So it goes from concave down to concave up at this minimum. So you're actually going to graph this function, making sure you're in radians, and then you're going to find this minimum value and give the x as your answer, the negative 1.192. 8 is actually no calculator whatsoever, right? It's just making sure you do a chain rule time and time again. So this is a 2-layer chain rule. Actually, it's 3 layers. You have negative x plugged into e, and then you have that plugged into sine. So you have 3 layers, right? So you should have cosine as your outermost derivative of keep e to the negative x plugged in, times the derivative of e to the negative x is e to the negative x, and then times negative 1 for the derivative of negative x. Okay? So that ends up, if you factor, what did they do here? Just kidding. What's going on? Oh, it's just rewritten the other way. Sorry. Sometimes they might have a product rule with this included, and you would have to factor to get your answer, but just noticing how it's rewritten, that would give you E for your answer there. Okay.